All right, today we are going to continue our discussion of the sine and cosine functions. Okay, and yesterday we talked about, we graphed the sine and cosine curve, and we talked about that the period of these curves is every 2 pi. So for example, if here's the unit circle again, once again. So here's 0, here's pi over 2, pi, 3 pi over 2, and 2 pi, right? So now, if we look at, here is a graph of the sine curve. This is the sine curve. How do you know it's the sine curve? What tells you this is the sine curve? It starts at 0. And what's the amplitude? 1. Now, where did these 5 points come from? Just to review yesterday what we talked about. What we did was we made a table. The table consisted the x value, it's not going to hurt repeating this, the x value are the angle measures. Now I'm only going to list the x and y axis angles. So just to refresh your memory, where did these points come from here? Well, what's the definition of sine? Sine is opposite or y value over the r value. So at 0, what is the y value? It's 0. And remember, r is 1 here. Here, 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 and here r is 1. So we started off with 0, then at pi over 2, the y value is 1, 1 over 1. And at pi, the y value is 0, 0 over 1. And at 3 pi over 2, the y value is negative 1 over 1. And again, another 0. So where are these 5 points? Well, 0, 0 is right there. Pi over 2, 1 is right there. And then pi 0, 3 pi over 2, negative 1, and then 2 pi. Now what's going to happen is the pattern is going to repeat. So this is one full period from here to 2 pi. And then that cycle is going to continue. So now, this question says, state all. All is an important word. And it should be bold, it should be bigger font. The word all means this. That's important. Very important concept. State all. If they said state all of the values from 0 to 2 pi, if I said from 0 to 2 pi, give me all of the values for which sine of t is negative 1. Where in here do you see that the sine of t is negative 1? From 0 to 2 pi. This would be the answer right here. It'd be 3 pi over 2. So at 3 pi over 2, the sine graph is a negative 1. It's right there here on the graph, and it's here on the table. But when they don't give you a defined interval, and it just says state all, they mean all from negative infinity to infinity. So what you need to understand is that the period is 2 pi, 0 to 2 pi, and it repeats. It's going to repeat here at negative 1, and again, and again, and again, and back over here. And it goes on, it goes from here to, you're going to add 2 pi this way, and you're going to add 2k pi that way, and you're going to subtract 2k pi this way. What's k? K is number of times. So this would be one more time. So 2 times 1 pi. And then over here would be 2 pi. 2 times 2 pi. And then 3 pi. 2 times 3 pi. And then 2 times 4 pi. And then going backwards. This is 2 times 1, negative 2 times 1 pi. And you're going to keep going. So how will you write this answer correctly here? Where do you see it starting at negative 1? It starts at 3 pi over 2. and you're gonna add and subtract multiples of 2 pi. This means multiples. Multiples of 2 pi. We put the k in the middle. So that's your answer. That's the correct answer. Now, when you start taking these tests, you have to read the directions. If the directions say, state all of the values for which sine is -1 from 0 to 2 pi, that's the only answer. You just say 3 pi over 2. But because it said all is meaning from -infinity to infinity, you have to write that down. It's important. Because the period is 2 pi. Check out this next one. This is the cosine graph. How do you know it's the cosine graph? Because it started high. Now, where did these points come from? Just to refresh your memory. Well, what's the definition of cosine? Cosine, by definition, is x over r. So at 0, and at pi over 2, and at pi, and at 3 pi over 2, and at 2 pi, where do you get these numbers at? Well, look at the unit circle. At 0, what's the x value? 1. So 1 over 1 is 1. At pi over 2, what's the x value? It's 0. 0 over 1 is 0. At pi, the x value is -1. -1 over 1 is -1. At 3 pi over 2, the x value is 0. 0 over 1 is 0. And at 2 pi, 1 over 1, which is 1. So that's where these numbers come from. So we have 0, 1, 0, -1, 0, and back to 1. Now let's read this graph, this question. And by the way, let's highlight 0 to 2 pi. There's 0 to 2 pi right there. This question says state all of the values of t for which the cosine is 0. Well, do you see where there's 0? Right here. That's when the y value is equal to 0, and here's another place. So on the table, I see it. Here's an answer, and here's an answer. On the graph, where do you see it? Do you see it at all? It's right here. That's your 0, and that's your 0. So these are the two, that's the picture, and here is the table. So how would you write this answer? Well, understanding that each of these points, this point is going to repeat, this is 2 pi units later. This point is going to reappear over here, which is 2 pi units later. This point is going to reappear here at 2 pi units later, and so forth. And it's going to go another 2 pi, and another 2 pi. So how would you write these answers? Pi over 2 plus and minus multiples of 2k pi, and this one is 3 pi over 2 plus and minus multiples of 2k pi. So there's two answers for this one, because it appeared twice. If I said, state the value of t where which cosine is equal to 1, if I said it's equal to 1, you would say it occurred at 1, at 0 plus 2k pi, minus plus or minus 2k pi, and at 2 pi. Now, this is repeating itself. If you took 0 and added 2 pi, you'd be here. So for this one, you don't, common sense, you don't have to write both of them because you're picking up these answers. But for this one, if you just wrote pi over 2 plus or minus 2k pi, your next answer is going to be here, and you're going to miss this answer. Now, there is another way to write this answer. can anyone think of a shorter way to write these two answers, but pick them all up? Can anyone think of another way instead of 2k pi? Can you write this a different way? Start with pi over 2. When did it occur again?
3,
How many units is it from here to here? Huh?
2,
No,
1,
from pi over 2 to pi is a half pi, and from pi to 3 pi over 2 is another half pi.
so 1.
So that's 1 pi. So you could do that, and by doing that for this one, it doesn't always work on these, but this one you're gonna see it happen at every pi. Is the answer. So you could shorten that one up. Okay? Now, check this out. Yesterday, we talked about the domain and the range of the sine and the cosine curve. The domain was all real numbers. This is what we wrote on our notes, ARN, all real numbers. That's what that means, negative infinity to infinity. The range, it went, all of these cosine and sine curves, the max and the min were 1 and -1. So the range was from -1 to 1. Make sure when you do your range, you always do the smallest number and then the largest, okay? So now, how does the range, we will alter the range when there's a vertical shift or a change in the amplitude. Do you remember us talking about this yesterday? So here's an example, look at the back. You're gonna have a question on your test, and it's not gonna give you a graph, and it's gonna ask you what's the max, the min, the domain, and the range. The domain is easy. It's what? All real numbers. So I don't care if you write it ARN or negative infinity to infinity, it means the same thing, okay? So the domain for the sine and cosine graphs is gonna be all real numbers. The range, it's going to change depending on if there's a different, it's not gonna be -1 to 1 if this is not a 1 and that's a 0. So do you remember my little trick yesterday, how I showed you the shortcut way to figure out the domain and the range? I mean, you could see it right here on the graph. This is graphed for you already. Can you tell me the highest and lowest number? That's 2, this is 1, and this is -3. So what is the range? From -3 to 1, that's the range, right? From our picture. Let's say I don't want to graph it. How could I have gotten that answer? Do you remember my trick? You do 2 times 1 minus 1 and 2 times -1 minus 1. So all you're doing is taking this cosine right here and replacing it for a 1 and a -1. So do the math. 2 times 1 is 2, minus 1 is 1, and -2 minus 1 is -3. Check this out. There's your max and your min. So your max is 1, your min is -3, and your domain, your range is now from -3 to 1. So let's say, I'll give you another example. So I don't want to graph this one. So how do I find the max, the min, the domain, the range, all that? You're going to do 4 times 1 minus 2 and 4 times -1 minus 2. So this you get 2, and this one you get -6. So that's your max, that's your min, your domain is all real numbers, and your range, how are you going to write the range correctly? With brackets, because it's going to reach those two numbers. Does that make sense? Okay. Another thing that you need to recall is, do you remember, I think it's chapter 3, not sure if it was 3 or 4, but we talked about even functions and odd functions. Like, for example, we talked about, that's an even function. What does even mean? Even means if you were to cut this along the y-axis and fold this over, or just fold it over along the y-axis, it has symmetry. And if it has symmetry to the y-axis, it's an even function. Well, which graph is even? One of them is even. Which one is this one? What graph is this one? Which graph is it? What is this? What's the name of this? This is the cosine graph. The cosine graph is an even function. It has symmetry to the y-axis. If you check this out, if you were to take this and fold it along the y-axis, you would see the symmetry. What curve is odd? What curve is this? This is the sine curve. This is the sine curve. This has symmetry to the origin. It's an odd, remember origin, odd, that meant the same thing. How do I know? Check this out. Do you remember this? You draw a line through the origin. These are going to be equal. And also, the points are going to be opposite points. So, if this is pi over 2, 1, this is pi over 2, comma 1. What you're going to have here is negative pi over 2, negative 1. And that's what, remember, that's the whole thing with odd or symmetry to the origin. You change the x and the y, they're going to both be opposite. Okay? You remember that?
Yeah.
So on your test, where is this going to come into play on your test? I'm going to give you a graph, and I'm going to say, is this odd or even? And you got to know. Okay? So memorize odd. Odd is sine, even is cosine. Last question. For what values they graphed, this is the what curve, sine or cosine? Cosine. This is the cosine curve. How do you know? Because it started high here. They graphed this interval, negative 2 pi to 2 pi. Okay? They want to know, tell me what interval the graph is increasing. What does that mean? You always read a graph left to right. So if we started here, are we going up or down? Down. So right here to here, it's increasing. Do you agree?
Yeah.
And then here it's going down, and then from here to here, it is increasing. So how are you, see if you remember how to do this stuff. How will you give me the intervals, there's 2 intervals here, that it's increasing? How would you write it correctly? You always start at the smallest. What would you write? Should I put a bracket or a parenthesis for this number right here? A bracket? No, we're going to use a parenthesis. Because it's not increasing or decreasing, it's nothing right there. It's not increasing, it's constant, right? No? Remember we did these in chapter 3?
Yeah, that was
So from here to here, what's this number right here? 0. And from pi to 2 pi. That's the intervals where it's increasing. Do you remember? Is it coming back a little bit?
Yes.
What if I asked you what interval is it decreasing? What would you tell me? If I said decreasing interval.
Negative 2 pi to negative
Negative
pi.
2 pi to negative pi.
0 to pi.
And 0 to pi. Parentheses, no brackets. Good. So that's what they're going to ask you. So if you flip to the next page, that's your homework. Not that. That's tomorrow's notes. Go to this page. Only do the questions that are sine and cosine questions. So now, for question 1 and 2, this is like your homework from yesterday, but I didn't include a graph. You're going to have to freehand it. They want to see if you can graph the sine curve from 2 pi to 6 pi. So in other words, it doesn't start at 0. So what you have to do is you may want to go like draw draw your picture, and this is 0, and then do 1, 2, 3, 4, that's 2 pi. So that's pi over 2, pi, 3 pi over 2, 2 pi. And then do 1, 2, 3, 4, that's gonna be 4 pi. 1, 2, 3, 4, I'm kinda going. So this is 4 pi, 1, 2, 3, 4, and that's gonna be 6 pi. So this graph should only be here, from here to here. So what you might wanna do is start here, draw your graph, and then erase or do like a broken part, because I only want this part, that interval, from 2 pi to 6 pi. Don't do, you might need to do 0 to 2 pi to start the pattern. But then your answer, you might want to darken it maybe, and do it that way. So this is like building on what you learned yesterday, the basic graphs. So that's your homework.